Okay, so hey everyone, the problem is you have to design a URL shortener system for millions of users, and in this URL shortener system, user can pick any alias, and if that alias is not present, then we can suggest some alias corresponding to what user has just typed. Okay, so let's see how we can design this system. First of all, of course, we have a client that will call to our servers, and let's suppose if we have a very high chunk of users, then we can distribute the request to multiple servers, and here we can use a dynamic load balancer. And here in this dynamic load balancer, you can pick any sort of uh, routing algorithm you want to pick. For example, least connection, priority assignment, consistent hashing, or round robin, weighted round robin, anything that you want. So that it's totally depend upon your use case. So once the request is to server, it will come in our backend. Now here in the backend, first let's talk about what if use in our system we have to check whether the corresponding alias that user has just typed is present in our system or not, like whether it is present in our database or not, right? So here, what are the best strategies to find out this in a very efficient way? Okay, so if you are just thinking about, hey, like in the backend, just call the database and pick it. So that would be not a good option, because ultimately you have millions of queries, and each query, if you just go to your database, then your database would definitely shut down. Okay, because of heavy, expensive disk IO calls. Okay, frequently. So now, if you are thinking, let's use indexing and all, and then try to like search. That is also that is a slightly better way corresponding to, like, as compared to what we were doing earlier. But I would say, hey, there is one more efficient way if you can think something in a different direction. So here we can use Redis Bloom filter. So Redis Bloom filter is a in-memory database. Okay, that, like, it's a basically hash based database, right? So you can just find out the corresponding availability of alias in a very constant time. Okay, it's just 32 bits or 64 bits corresponding to what is the maximum length of alias you can like a user can pick, right? So for this we can use Redis Bloom filter, of course. But we know Redis Bloom filter is a probabilistic function, right? So if Redis Bloom filter says, hey, I am saying this data is not present in my set, that is 100% guaranteed, right? So if that condition is coming, so we are returning the response. But when Redis Bloom filter says, hey, this data might be present in our system, so that's a probabilistic condition. Now why this probabilistic condition coming into the picture? Because we know Redis, the internal working of Redis Bloom filter is it works upon bits, right? So if corresponding to multiple, let's suppose there are two aliases, right? And for those two alias, there are some bits that are common in between them, which is already marked as true. Now we can't differentiate between those two alias, whether those two alias has been taken up or not already. So that is why it's a situation of probability. So now we are going in our Redis cache. So Redis cache is that place where we are storing some of our frequently taken aliases for some amount of TTL. For example, 24 hours or corresponding to what time you wanted to take, right? But Redis cache has two conditions. It's, let's suppose if it's a cache hit condition, so we can just return the response. You can see here it's a cache hit condition, so just return the response. But let's suppose if it is a cache miss condition, so now here we can go in our database shard. So again, this is not my entire database, it's a database shard. So how we can redirect our request to specific database shard? We can use any consistent hashing algorithm again here, for example murmur hash or any cryptographic algorithm. Okay, then we can, in our database shard, we have indexing that works upon b plus trees, right? And via that we can find out that but like we can find out the result corresponding to particular alias in log and time complexity. So you can see it's a three level of filtering that we are doing. First we have Bloom filter, then we have Redis cache, and then last we have DB shard. And in the DB shard, let's suppose the alias is already taken up. So we are saying, hey, just return the response because the alias is already present in my database. Somebody has already taken it up. But what if this alias has not been taken up yet? So now it's a condition of user can take this alias. So okay, now let's allow user to take this alias. And now the thing is, we would update this alias in our database, plus we would update this alias in our Redis cache, plus we would update this alias in our Bloom filter. So now here two things comes into the picture. First is, what if we do this updation operation synchronously? Or second is, what if we do this updation operation asynchronously, which is more better? Definitely asynchronous operation. Why? Let's assume you have updated your alias in database shard, right? And after this you are updating in your Redis cache or you are updating in your Bloom filter. Now here you can assume any of this updation operation either in Redis cache or in Bloom filter or both gets failed. So it's a API failing condition, right? So you will get an error in your API, but you'll get an now you are getting an error in your API, you are returning an error, but ultimately database shard has already updated, right? Like the new alias has already been updated in database shard. So that's a problem, right? Either you have to now remove again that particular alias in your DB. So it's like expensive double operations that you are doing. So that's why instead of making it synchronously, let's make it asynchronous. And for that we can use any SQS, any messaging queue service. For example, I am using SQS, and in my SQS I am adding this event that just update it in my Redis cache with 24 hours TTL or maybe any 12-hour TTL. That's depend upon your traffic count. And as parallel you are updating in your Redis cache, update in your Bloom filter as well. Now you must be wondering why we have added this Redis cache and why we are adding our recently taken alias in Redis, right, with some TTL. The reason is pretty simple. Let's suppose there is a trend that is going viral on internet, right? And now see, if any trend is going viral on internet, then there are highly chances that many people will try to take that alias name corresponding to that trend, right? So let's see, if you have on a very frequent night or day, you just got very huge chunk of traffic, and many people from there from that traffic are picking similar kind of aliases, right? Then it's better to just add Redis, just add that particular alias in Redis with some time to TTL, so that your DB won't face any heavy load. Okay, now the last thing remaining is, I said earlier we can suggest aliases as well, right? So what are some suggestion, I would say, what are some algorithm or techniques that we can use to create suggestions, right? So the very first thing is we can use try for suggestion. Now why I'm using try? See, we know, if we search anything on Google search, it automatically starts predicting our next word, right? So that entire searching algorithm is built up upon try data structure. So that's the same reason why I am using try here. You can build your entire try, and then you can predict next word, so you can suggest it, right? And along with that, you can also have some libraries, for example adjective, noun, some separators or anything that you want to append. For example, let's suppose if user is taking an alias Pratik, and I can create a suggestion having adjective, a separator, and then my name. So it would be if I am taking adjective as cool, so it would be cool underscore Pratik. So it's one more suggestion that I have created. And the third one that you can take is any fallback mechanism. For example, you can generate any random username, any random from any random library, right? So why I'm like, it's totally depend upon you how many level of generation you want. That's totally depend upon your use cases. And of course, once you have generated the suggestions, you have to check in your bloom filter as well. Like, you have to pass these suggestions to your bloom filter, right, to check whether these suggestions has already been available or not. So it would be like, you generate some suggestions and then flow will go from here to Redis cache to DB shard. Okay, understood. So yeah, that's all I wanted to talk about in this video. I hope you have understood how URL shorteners can work into, like, in very millions of users scope, right? And I hope you can now think of how you can design a system in interviews, what things you have to take care of, how you can make it scalable, make it extensible. And see, let's suppose if suggested alias is a feature that has not been added yet, then still our design is very extensible. Like, see, if this is my design, then I have built this suggested alias on top of it, right? So that's how you have to design system, so that whatever you are building right now, you can make things on top of it, so that you don't have to make, like, you have to, the your main motive should be you have to make very least changes, right? So yeah, thank you for watching this video. I hope you have liked it and you have learned something new. Hope you have a nice day. Thanks.